Computer Science A, Unit 10, Recursion. This is Lesson 2, Binary Search. Objectives include understanding how the binary search algorithm finds a value in an ordered array of data, writing the code to implement the binary search algorithm in Java, and understanding the advantages and disadvantages of using the binary search algorithm to find data in an array. Now you might be saying, haven't we already done this? We did. We used the binary search algorithm using a loop. We're going to look at how you could also implement it through recursion. If we were to search for a particular word in the dictionary using the linear search we covered previously, we might be reading words for a very long time, especially if our target word is towards the end of the alphabet. However, a binary search can find our target word in a much shorter amount of time. A binary search finds the element in the exact middle of our data set and compares that value to our target value. If the midpoint value is too low, we know we don't need to look at any of the values from the lower half of the set because they will also be too low. Just like that, we have eliminated a full half of our data set. With the other half, we can again split that part in half and run another comparison. Each time we do this, we eliminate half of the remaining possibilities, closing in on the target with exponential speed until we find it. There is one rule for using a binary search. The data set we're searching through must already be sorted. If it's not sorted, then the binary search won't work. Now, pseudocode. Here's a blast from the past. Find the value at the midpoint. Okay, so you do the low index plus the high index divided by 2. If our target value is lower than this value, repeat with the high equal to mid minus 1. Otherwise, if it's higher than this value, repeat with the low being mid plus 1. Repeat until we find our match, or high is less than low, which means the target doesn't exist in the set. Okay, little down memory lane. This was the pseudocode. So as an example, if we want to search for the number 32 in the list below, the first thing we do is we find the mid value. So right here's our middle index, and it is 34, but we're looking for 23. 34 is greater than 23. Therefore, we're going to look at the lower half. The value in the middle is more than what we're looking for. So, that being true, I can then say I know it can't possibly be in the upper half. So now, I'm just going to look at the lower half. And when I look at the lower half down here, 20 is the value that's in the middle. Well, 20 is less than 23, so that means my value can't possibly be in the lower half of this remaining list. Therefore, I'm going to look above it. Now, if mid is between two numbers, so I'm looking at, I only have two values. If mid is between two numbers, integer division will occur, and I'm going to use the bottom half because I get whatever 0.5. And remember that the decimal part is just truncated. So when I just have 23 and 33 I'm looking for, this value, 23, is the one that is the middle. Well, 23 equals 23, and therefore I return 3, which is the index in the original list of the value. Remember, I'm not actually destroying my list. I'm just narrowing in my indices. So here's my indexes: 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So again, 5 was the middle because I did 0. 0 plus 10 was equal to 10 divided by 2. I looked at element 5. Then I came down here, and remember now I had 0 through 4, so I'm going to look at 0 plus 4 divided by 2 was 2. I'm looking at the item in location 2. When that didn't work, then I'm looking at 3 and 4. So this was 3 plus 4 divided by 2 is 7, divided by 2 is 3.5. But again, integer division truncates the decimal portion, and so I'm going to look at location 3. And location 3 does hold 23. That is the value I'm looking for, and therefore that is the value that's returned. Now, in terms of code, there are several ways you can code a binary search. You can do this iteratively using a for loop or a while loop, or recursively, having your method call itself. I can walk through this, and I'll do it very quickly, but you should also pause the video and make sure that you understand what's going on and compare it. Okay, notice that in both cases, it's just called binary search. You pass it an array, and then on the left, okay, notice I've passed it a target, just the value I want to find, okay? So then I set the low to 0, the high to the length minus 1 of the array, and now I'm going to loop through the array. Calculating the middle, notice low plus high minus low divided by 2, and this is because we keep moving it, okay? Then if the array at the middle is equal to the target, we return that index. Otherwise, if that value is less than, we reset the low. If it's greater than, we reset the high. And then, oops, here is my loop. So it goes all the way through the loop. If it goes all the way through the loop and it eventually gets to the point where the low is greater than the high, then I'm going to return -1 because -1 can't possibly be an index. So everything's going to happen in this loop. If I'm going to use a binary search using a recursive algorithm, we pass it the array, int y, int r, int x. If r is greater than or equal to 1 and 1 is less than the array dot length minus 1, then we're going to go in here. This says I actually have something in my array, because remember, when we pass stuff, we're going to keep passing a smaller and smaller array. So mid is set to y plus r minus 1. Okay. Notice those two look very similar. If array is in the middle, we return the middle. If array is above it, we return binary search array y, okay, mid minus 1 x. Notice x appears to be the target, right? Okay, so this is the target that we're looking for. This is our low, this is our high. Then we return binary search array mid plus 1 because y was our low. Okay, if we look at this, this was our low, this was our high, and this is our target. Okay, but we have to pass these because it's not, there's no way for it to know what it was before. So we pass all that to the binary search. Up here, this is making sure that we still have things to search in our array. Now, if this is not true, we return -1. So this right here, okay, essentially is our base case. It hasn't been found. We've gone all the way through the array. Now we got all the way down to a binary search in the recursive algorithm, and it wasn't there. Or there's nothing. We just passed the empty list to our binary search, and it says, well, if it's an empty list, then nothing's there. So it returns -1, which returns -1, okay, because it would return -1 to here or here, which would then return -1, etc. Right? You should understand both of these. And again, you could use low and high instead of x and y if you'd like. Linear search versus binary search. If you haven't noticed, this is a second lesson on the binary search. You already had one in the loops in the iteration. So it's very important. Linear search versus binary. Compared to a linear search, the binary search has some distinct advantages and disadvantages, especially over large sets of data. The binary search can be very fast. However, it can be a little tricky to code, and the data set you're working on must already be sorted. Okay? The binary search is not straightforward. You don't just look, discard, look, discard, look, discard. Okay? And if it's not the binary search, when it says it won't work at all, it won't work with certainty. All right? You could get lucky and you might find the data. It's not 100% that you won't find the data, but it would be by coincidence. So it's not guaranteed that you would find it using the binary search if you don't sort your data. The advantage, it's very, very fast. Disadvantage, it is more difficult to code and the array must be sorted. So if you're constantly getting an unsorted array and it's a very large amount of data, and every time you search you have to resort, that might be a problem. Now, for the AP exam, it is important to understand the differences between our two types of searches, the linear search and the binary search. That concludes Unit 10, Lesson 2.